Hello, welcome to this lesson of our study of integral equations. And in this lesson, we'll go through another example of solving or converting an integral equation to a differential equation. Okay, specifically converting a Volterra's integral equation to a differential equation. Okay, so if you have not subscribed to my channel, kindly subscribe to support the video. Okay. Alright, so the example we have here is that we are supposed to do this conversion of the function u of x equals 2 plus 2 plus 3x. Okay, I'm coming. Alright, so we are supposed to convert the function 2 plus 3x plus 5x squared plus the integral of the whole expression that this one, the limit is 0 to x, and this makes it a Voterra's integral equation. Okay, so with this, like we said in the first example, we said that you use a method that is called the Leibniz rule of differentiation under the integral sign. Okay, so you have to record this, that if you have a differential or ddx of an integral like this, then this is the method we apply. Okay, so we said that it will be equal to f of, so we have a function of two variables, f of xt. Okay, so the whole of this differential will be equal to the function evaluated at sb, that is f of xb times the b dx minus f of xa times the a dx plus the integral again. Okay, then the partial derivative of whatever that was under the integral sign with respect to x. Okay, so with this one, we have this. To convert this to a differential equation, quickly we have to differentiate the whole of the equation. Okay, so differentiate everything here with respect to x. When we differentiate u of x with respect to x, we don't know u yet, so we have u prime of x, or simply let's call it u prime. Okay, I'm sorry, let me write it well. U prime is equal to, then you differentiate 2, you get 0. Okay, then you differentiate 3x, you get 3, plus the differential of 5x, that will give me 10x, plus the differential of ddx of the whole of this integral. Okay, 0 to x 1 plus 2 into x minus t, then u of t dt. Okay, u of t dt. Alright, u of t dt, like that. So you're supposed to go and differentiate this. So with that, you apply the Leibniz rule. Okay, so here, if I'm to apply the Leibniz rule here, then my f of xt would then be equal to 1 plus 2 into x minus t, all of these multiplied by u of t, because with the Leibniz rule, realize that everything here apart from the dt is your f of xt. Okay, everything here. So you go to this one, you apply the same thing. Then what you do is you evaluate the function at the point b. Okay, so f of xb, meaning our t in the equation. Okay, you realize that we have f of xt, so we have to evaluate our f of st here at f of sb, meaning our t will just tend to b. So we just look at what b is and put it there. Then we find a differential of b with respect to x. Okay, I hope you get what I'm trying to say here. I'm sorry, let me use a blackboard for you. Okay, so what happens here is that with this, I said our f of st is that, and when you evaluate it at b, where b is what? B is x this time, so f of xb will be what? Meaning that our t will tend to b, which will be x. So we just evaluate f of x. Okay, so let's go through that together. So with this differential, our f of xt, like I said, is given by 1 plus 2 into x minus t, or multiplying u of t. Okay, Then our f of xb is the same as f of xx since our b is x. Okay, so you put wherever I see b, you put x there. Okay, and then it becomes f of ss. Already have f of xt here. Now the only thing that changed was just the t. So it means that through this equation or through this function f of xt, wherever I see t, I put in x. Okay, so here there's one t here, I put in x, it will become x minus s. That will give me 0. So I'll have 1 plus 0 or multiplying u of t, but then t is turning to x, so it becomes u of x. So I have 1 times u of x. So it will be like this: 1 plus 0 times u of x. And in effect, I'll get something like 1 plus 1 times u of x, and that will give me u of x. Okay, so now let's go to the next one. We differentiate b with respect to x, and b here is what? X. So if I differentiate x with respect to x, I'll get 1, and that is it that I have here. Okay, now I evaluate my function f of xt at f of xa, and here our a is what? 0. Okay, so come and then put a equals 0. So it means that wherever I see t, I put in 0. So if I put 0, let's come to the f of st. If I put 0 at t here, I'll get x minus 0, and that will give me just x. Then multiply by 2, I'll get 2x here. Okay, then u of t, and t is now 0 because the x was maintained here. It was maintained, but it was the t that changed to 0. Okay, so it means that my t will be just 0. So I have u of 0. Now I differentiate a with respect to s, and our a here is 0. So I differentiate 0 with respect to x, and I'll get 0 as well. Okay, so that is it. Now let's go and then put it in the solution. So we said that we'll have to also find del f of st del x. Okay, let's go back to the Leibniz rule, and I'll show you what I'm talking about. In the Leibniz rule, realize that there is this term here, del x of f of st, meaning you differentiate f of st with respect to x. So you go back to your question, then you take your f of xt, you differentiate it with respect to x. Now if you can't do this differentiation just straight away, let's say looking at this, someone may look through it and then know that, oh, this is the differential. If you can't do it straight away, what you do is just expand this side. Okay, and yes, when you get 1 plus 2s minus 2t all times u of t, and now u of t is a constant because you are differentiating with respect to x, so u of t becomes a constant, and 2t will become a constant. One will become a constant. Okay, so what you have to do is just differentiate the whole of this bracket and multiply it to this constant. Okay, or you can go ahead and again expand this and differentiate them term wise, but I think here will be okay. So you differentiate 1, you get 0. You differentiate 2x, you get 2. You differentiate minus 2t, you get 0. So I have 2 times u of t. Okay, so I have that as well, like this. So now you quote our formula back, that d dx of the integral from a to b f of xt dt is giving us f of xb db dx minus f of xa dA ds plus that. So now what you do is you just go back. F of sb, we had what? It was f of xx. That gave us this u of x. Okay, now its derivative db ds gave us 1. So when you multiply them, you get u of x. So that is what I have here. That's what I have, my u of x here. Okay, then minus f of sa times dA dx. Now you go to f of xa, you have this times the ds gave us 0. So when I multiply it to that, I'll get 0. So it means that this term will just go to 0. Then I have integral from a to b. Here are a and b didn't come, I didn't write it, so it's 0 to x rather. Okay, 0 to x. So then del x of that, and del x of f of xt gave us 2u of t. So I just come and put it here. This is very simple, right? So just cool like that. So our next task is to come and put this solution that we had here back in the question. Okay, so in the question you differentiate up to this point. So at this point you just come and put whatever result we had there. Okay, So we said that the differential gave us u prime being equal to 3 plus 10x, okay, 3 plus 10x, then plus u of x plus, then what did that integral or the differential under that integral sign give us? It gave us integral from 0 to x, then 2 u of t dt. Now there is still an integral sign here, so what we can do here is that we can as well continue and differentiate the whole of this integral equation again, because there's an integral sign here, so we don't want to see any integral sign at the end. Okay, so what we have to do is continue again and differentiate with respect to x. So if I differentiate u prime with respect to x, I'll get u prime prime, okay, u prime prime, and that is equal to, when you differentiate 3 with respect to x, you get 0. When you differentiate 10x, you get what? 10. Okay, then plus you differentiate u of x, you get u prime of x, and plus ddx, okay, ddx of the integral from 0 to x to u of t dt. So what you can do here is, at the same time, you go and work for this side as well, okay? But this time, let's go through it together. I hope you get my point. Let's go through it together. So for that one, my f of xt here would then be equal to 2u of t. Okay, 2u of t. And what I have to do is I have to find my f of x b, which is the same as f of xx, okay? Meaning wherever I see t, it changes to x. Okay, so it becomes 2u of x. Okay, then we continue and find our f of xa. Or let's do this first. You have to do the b dx, okay? We said the b dx, so the b dx, and that is equal to, just differentiating b is what? X, so d dx of our x, and that will give us 1. Okay, so let's go to f of xa. Okay, and it's equal to, wherever I see t, it changes to a, so it becomes f of x comma a is 0 in this context, so we'll have 2u of 0. Okay, I hope you get this. Now the dx is equal to d dx of 0, and that is equal to 0. Now we have to find del x of our f of xt, and that is equal to del x. Our f of xt here, we said, is 2u of t. Now this is a function of t, so when I differentiate with respect to s, I'll get 0. Okay, so our equation here, everything I have here will then tend to become like what I'm coming to write. Okay, so we have, if you quote your Leibniz rule, you have u prime prime is equal to, now I have 10 plus, okay, 10 plus u prime, then plus, with the Leibniz rule, we just f of xx times is the differential of b with respect to x. So what is my f of xx? So it is my f of xx times the differential, and that is 2u of x. So I have 2u of x, okay, or I can call it u. Let me just call it u. Then minus f of xa, this one, times its differential, that is 0. So 0 times 0 becomes 0. Then plus the integral, okay, from 0 to x. So here our a is 0 to x, which is our b, of del x of f of st, and that is 0 dt. So in effect, this side will also be 0. Okay, so let me clean it. A definite integral of 0 is always equal to 0. So let me clean that one and then put it there. I'm just taking my time to go through it. Okay, plus 0 like that. So here, all that I'll be left with will be u prime prime is equal to 10 plus u prime plus 2u. And this is your required differential equation. So you can rearrange terms and write it to u prime prime minus u prime minus 2u is equal to 10, which is a non-homogeneous second order differential equation. Okay, so this is what we're looking for, and that is all. So if the question asks you to continue and solve it, then you apply the necessary differential equation method that you know the solution to differential equation method that you know, then you solve it. Okay, thank you, and don't forget to subscribe to my channel if you have not subscribed. Like my videos, comment, and also share it for others to benefit from it. Okay, see you next time.